Okay, this video looks at another type of algebraic solution called solving systems by elimination. So the first thing that we need to go over is just making sure you're comfortable with adding and subtracting negative numbers. So minus 5 plus 2 is minus 3. 5 plus 2 is 7. 5 plus minus 2 is positive 3. Minus 5 plus minus 2 is minus 7. Okay, and then subtracting, we've got almost the same thing. So 5 minus 2 is 3. Then we've got minus 5 minus 2, which is minus 7. 5 minus minus 2 is positive 7. And then minus 5 minus minus 2 would be minus 3. Okay, the reason we need to do this is because we're going to be adding terms of an equation together, and it's important to be comfortable with the signs. So to solve a linear system by elimination, what you are doing is adding or subtracting the equations to eliminate one of the variables. So first step is through multiplication, obtain the same coefficient in front of one of the variables. Second, decide whether to add or subtract the equations. Add or subtract, perform the actual operation. Solve for the remaining variable. Substitute the values for the variable into one of the equations. Solve for the second variable. Write a concluding statement, and then check your solutions. Okay? So these first three steps are what's different than solving by substitution. Once you solve for that first variable, everything else is the same. So let's look at a couple examples. So we're going to solve these two systems by elimination. So I'm going to label my equations 1 and 2. And what I'm going to notice is that I have the same coefficient in front of the x. So if I subtract those equations, so equation 1, take away equation 2, that is going to eliminate my x variable, because 3x take away 3x is 0. Now I'm doing the same thing for the y's, minus 4y minus positive 7y. So I'm going to end up with minus 11y. Now I'm doing the same thing, 14 minus negative 8, which is going to give me positive 22. So here, this is a good example where you can see why it's important to make sure that you have your signs straight. Now I can divide both sides by minus 11, and that gives me y equals minus 2. So now that I've solved for one of the variables, I'm going to take that and substitute it back into one of my equations. Doesn't really matter which one, I'm going to pick the second equation. So here we go. Sub y equals minus 2 into my second equation. So I've got 3x plus 7 times minus 2, my solution for y, equals minus 8. And now I can solve for x. So 3x equals minus 8 plus 14. 3x equals 6, x equals 2. So therefore, my solution is 2 minus 2. And I can check by substituting into my equation and make sure it satisfies my other one. So let's check. So looking here at equation 1, 3 times 2 is 6, minus 4 times minus 2, so that's going to give me 8. So my left side of this first equation, so right here, I would have 14, matches my right side of 14. Let's look at another example here. So I'm going to start off by labeling my equations again. And now I'm going to look, none of my coefficients match. So the first thing that I want to do is I'm going to multiply my second equation by 3. So now I've got a new equation, 3x minus 3y equals 9. And this is my third equation. Okay, so I'm going to write my first equation underneath, 3x plus 3y equals 21. This is my first equation. And then now what I'm going to take a look at, my whole goal is to make my x's the same. And so I'm going to subtract my first equation from my third one. So 3x minus 3x eliminates that variable. Here, confusing because there's still a 3 in front of both y's, but because they're not the same sign, when I subtract, I'm going to get minus 6y here. Okay, and then on the other side, 9 minus 21 is going to give me minus 12. So now I can solve for y. I get positive 2 this time around, and I'm going to take this equation and I'm going to substitute it back in to my first one. You could do either equation at this point. It doesn't matter. So substitute y equals 2 into equation 1. So I've got 3 times x plus 3 times y, which is 2, based on my algebra, equals 21. And then I get 3x plus 6 equals 21. 3x equals 15. X equals 5. So therefore, my solution is 5, 2. Again, I can check that in my, let's go all the way back right up here to my second equation. On the left side, I've got x minus y, 5 minus 2, which is 3, which matches my right-hand side. So I know that my equations, my solutions are correct here. Let's do one more example. Here we've got 5m minus 3n equals minus 5. This is equation 1. And then we've got 3m minus 2n equals minus 4. So what I'm going to notice is that they're not the same. The coefficients aren't the same. And then I can't just multiply one equation. I'm going to have to multiply both. So what I'm going to do is I'm going to multiply my first equation by 3, and then my second equation by 5. It's important to make sure that you multiply each part of the equation. So 15m minus 9n equals, don't forget about the right-hand side, minus 15. So this is my third equation. And then I'm going to do the same thing here. I've got, what am I multiplying by? By 5. So I've got 15m. That's good. Now I've got the same coefficient. Minus 10n equals minus 20, making sure I multiply each of those pieces to scale up the equation. Now what I can do is I'm going to do my third equation, take away my fourth equation. This gets rid of my m variable, and now I'm left with the n. So I've got minus 9n, take away minus 10n. So that gives me positive 1n. And now I've got minus 15, take away minus 20, which is adding. So here I'm going to end up with 5. So now I've got n equals 5. So now what I want to do is I'm going to sub n equals 5. And let's go into first equation here. So I'm taking my solution to one variable and I'm plugging it back in to here. Really, it doesn't matter which equation you use at this point. I'm using one of my original ones just in case I made an algebra mistake when I was rearranging. It can help you catch your mistakes. So 3n, which is 5, equals minus 5. And then I've got 5m minus 15 equals minus 5. Oops, I said 5 and wrote 15. There we go. So I've got 5m equals 10. which means that m equals 2. So therefore, my solution is mn, so 2, 5. And let's just double check just for fun. Okay, so this would be our formal check. We're going to first check our left side and our right side in the first equation. So we've got 5m minus 3n equals minus 5. 5 times 2 minus 3 times 5 equals, let's see, 10 minus 15 minus 5. So that's good. And then we're going to check our second equation, left-hand side, right-hand side. And so we've got 3m minus 2n equals minus 4. 3 times 2 minus 2 times 2, which is 6 minus, 3 times 2, n is 5. So I've got 6 minus 10, which is indeed minus 4. Okay, so we've done our formal check. That's our solution. Solving systems by elimination is another algebraic method to solve a linear system.